In this video, we're going to be looking at multiplication and division of rational numbers. So in this case, we're going to be multiplying rational numbers. We're going to look at properties of multiplication of rational numbers, also multiplying mixed numbers, dividing rational numbers, estimation and mental math with rational numbers, and extending the notion of exponents. Now you have to think of multiplication as repeated addition, like in this case, 3 times 3/4. In this case here, we're adding 3/4 3 times. Okay, so it's like 3/4 plus 3/4 plus another 3/4. If you recall, the denominators are the same. We can add the numerators, so you'll end up with 9/4. And then 9/4 as a mixed number would be 2 1/4. In this, as you can see in this illustration, because you have 2 whole circles and 1/4 of a circle shaded. Multiplication can be thought of as part of an area. Let's say we have 3/5, which is shaded. 3 out of the 5 boxes are shaded. And then you take 1/2. So that means 1/2 going this way would be, in this case, 3/10. Because now the common shaded area is these 3 boxes out of the grand total of 10. So this is the notion of multiplication of rational numbers. If a over b and c over d are any rational numbers, then a over b times c over d is equal to a times c over b times d. In other words, you're going to multiply the numerator times the numerator and denominator times denominator. Like in this example, if 5/6 of the population of a certain city are college graduates and 7/11 of the city's college graduates are female, what fraction of the population of that city is female college graduates? So in reality, we're looking at 7 out of the 11 that are of the city's college graduates that are female, and then of those 5/6 of the population in that city are college graduates. So we're multiplying 7/11 times 5/6, which will be 35 over 66. Again, we multiply the numerator times the numerator and denominator times denominator. So to answer this question, 35/66 of the population is female college graduates. And here's some properties of multiplication of rational numbers. Some of them are quite familiar. One is the multiplicative identity. In this case, the number 1 is the unique number such that for every rational number a over b, 1 over a over b will be equal to a over b, or a over b times 1 will also give you a over b. So any rational number multiplied by 1 would be equal to that rational number. And the multiplicative inverse, this is another term for the reciprocal. For any non-zero rational number a over b, b over a is the unique rational number such that a over b times b over a is equal to 1. Or b over a times a over b would also equal to 1. Because if you take a rational number multiplied by the reciprocal, meaning you're just going to invert the numerator and the denominator, a over b becomes b over a when you take its reciprocal, or b over a becomes a over b when you take its reciprocal. And if you multiply that rational number and its reciprocal, the product will be 1. Then you got the distributive property of multiplication over addition. If a over b, c over d, and e over f are any rational numbers, then a over b times the quantity c over d and plus e over f is going to be equal to this. You'll just distribute the a over b through multiplication. So this product will become a over b times c over d plus a over b times e over f. That distributive property of multiplication or addition does apply to rational numbers as well as for integers and whole numbers. Also, the multiplication property of equality is this. If a over b and c over d are any rational numbers such that a over b equals c over d, then e over f is any rational number where, in this case, we can multiply e over f on both sides of the equation and get a true equality. So here, if a over b and c over d are equal to each other, then any rational number that I multiply on both sides will still give me a true equality on the left and on the right side. Now, the multiplication property of inequality. And of course, inequality has either less than or greater than, or less than or equal to, or greater than or equal to. In this case here, if a over b is greater than c over d, now if e over f is a positive number, if it's greater than 0, then if I multiply e over f on both sides of this inequality symbol remains the same. Now, let's say e over f is less than 0. That means if e over f is a negative number, and I'm using this multiplication property of inequality, what's going to happen is, if I know a over b is greater than c over d, what's going to happen is if I multiply both sides by e over f, and I know e over f is negative, the inequality symbol changes to the opposite. Okay? So if you recall back in algebra, when you were multiplying or dividing inequalities by a negative number, the inequality symbol changes direction. In this case, start off with greater than. When you multiply it by a negative, it will end up being less than. And the multiplication property of 0 means that if you have any rational number a over b, multiplied by 0, you're going to get 0. Or 0 times any rational number will be 0. Here's an example. A bicycle is on sale at 3/4 of its original price. If the sale price is $330, what was the original price? So here we have an algebra problem that we want to solve. We want to find out what the original price is, so we're going to let x be the original price. Then the sale price, that's going to be 3/4 of its original price, so that's 3/4 times x, which will be the sale price. And the sale price is $330, so the equation that I'm going to have is 3/4 x equals $330. Now to solve for x, I'm multiplying by 3/4. So it'll be easier, since I'm dealing with a fraction, it'll be easier for me to multiply both sides of this equation by the reciprocal of 3/4, which is 4/3. And when I do that, as you'll notice, these 4's will cancel, and so will the 3's. They too will cancel. You're left with x. So now you got 4/3 times 330. Okay, now you can do 4 times 330, which will be 1320. And then 1320 divided by 3 will give you 440. Or, think of this as 3 divided into 330. That's going to go 110 times. So 110 times 4 will give you 440. So the original price there will be $440. Okay, next we'll look at multiplication with mixed numbers. Okay, using improper fractions and using a distributive property. So there are two ways that we can do this. If we use improper fractions, then that means we have to multiply the denominator times the whole number and then add the numerator. So in this case here, 2.5 times 2.5, that'd be 2 times 2, which will be 4, plus 1, which will be 5 over 2. And 2.5 will also be 5 over 2. So we have 5 halves times 5 halves. We multiply numerator times numerator and denominator times denominator. This will give you 5 times 5, that's 25, over 2 times 2, which is 4. So you'll have 25 fourths. Rewrite this as a mixed number by dividing 4 into 25. That will go 6 times with 1 left over. So it'll be 6 and 1/4. And then using the distributive property, you can think of 2.5 as 2 plus 1/2. So it's written like this: 2 plus 1/2 times 2 plus 1/2. And then this 2 will be multiplied by 2 plus 1/2, and then the 1/2 will be multiplied by 2 plus 1/2. That's this expression right here. And then use the distributive property again. 2 times 2, that's 4. And then 2 times 1/2, or 1/2 of 2, will be 1. And then 1/2 of this 2 will be 1. 1/2 times 1/2 will be 1/4. So now if we add 4 plus 1 plus 1, you'll get 6, and then we can bring over the 1/4. So the final answer there will be 6 and 1/4. Okay. How many 1/2s are in 3 wholes? Now you'll think of this as 3 divided by 1/2. Okay, so here are 3 wholes. Each whole will be divided into halves. And we want to know how many 1/2s are there in 3 wholes. If you count these up, you'll see that there are 6 of them. So this is a representation of 3 divided by 1/2, which will give you 6. Okay, and then next is how many 1/8s are there in 3/4. Okay, so here, if we have 3/4, and then we split this up into 8s, and you want to know how many 1/8s there are, you have 1, 2, 3, 4, 5, 6. So this is another representation of 3/4 divided by 1/8 equal to 6. Okay. Using this number line model, how many 3/4 are in 7/8? Okay. So here, the bar of length 3/4, as you can see in blue, that's made up of 6 equal pieces of the length 1/8. Okay. 6 equal pieces of the length 1/8. And then there is at least one length of 3/4 in 7/8. So if we put another bar of the length 3/4 on the number line, we see that there is going to be one more of the 6 equal length segments needed to make 7/8. So here you got 7/8 divided by 3/4, which will be 7 over 6, or as a mixed number, 1 and 1/6. Okay. Now those are just some representations or visual representations of how we divide rational numbers. Okay, if we have a over b and c over d, they're any rational numbers, a and c over d is not 0, then a over b divided by c over d is equal to e over f. And that's if and only if e over f is going to be some unique rational number such that c over d times e over f will equal to a over b. Okay. Now here, a over b and c over d are any rational numbers, and c over d is not 0, then a over b divided by c over d is the same as saying a over b times d over c. In other words, when we multiply fractions, we always, when we divide fractions, we always multiply by the reciprocal of the second fraction. Okay? Anytime we divide fractions, we always multiply by the reciprocal of the second fraction. And when two fractions with the same denominator are divided, the result can be obtained by dividing the numerator of the first fraction by the denominator of the second fraction. Okay? Now, let me give you an example of just that. Let's say 4/3 divided by 2/3. Here the denominators are the same. So we can come up with our answer by just dividing the numerator of the first fraction by the denominator of the second. So in this case, 4 divided by 2 is simply 2. Okay. Now to divide fractions with different denominators, we rename the fractions so that the denominators are equal. And they give an algebraic representation of a over b divided by c over d. If you take the denominators, b and d, just multiply them together and come up with their equivalent fractions, you're going to get AD over BD divided by BC over BD. Now the denominators are the same, so you just do AD divided by BC. Or you can write that as AD over BC. Let's look at an example here. A radio station provides 36 minutes of public service announcements for every 24 hours of broadcasting. In part A, what part of the broadcasting day is allotted to public service announcements? Okay, so in this case here, we're going to convert this into minutes. 60 minutes is equivalent to 1 hour. So there are 24 hours of broadcasting, so 24 times 60 will be 1,440 minutes in a day. And 36 of those minutes is for public service announcements. So as a fraction, we'll write that as 36 over 1,440. And if you divide the numerator and the denominator by 36, you're going to reduce that to 1 over 40. So 1/40th of the day is allotted for announcements. Part B of that question, how many 3/4 minute public service announcements can be allowed in 36 minutes? Okay, so now we got 36 minutes, and we want to section that off into 3/4 of a minute. So that's 36 divided by 3/4. Now when you divide, you multiply by the reciprocal, so it'll be 36 times the reciprocal of 3/4, which is 4/3. So 36 times 4/3, which will be 48. So now 48 announcements are allowed. Okay, here's another example. We have 35.5 yards of material available to make towels. Each towel requires 3/8 yards of material. Part A of that question is how many towels can be made. Okay, so here we want to find the integer part of the answer to 35.5 divided by 3/8. Now for the 35.5, we convert that to a improper fraction by multiplying 2 times 35, which is 70 plus 1, which will give you the 71. So it'll be 71 over 2. Then times the reciprocal of 3/8, we invert the fraction, which will be 8/3. Sometimes they call the technique invert and multiply. So you're going to invert 3/8 to 8/3 and then multiply by 71 over 2, which will give you 284 over 3. Now, where did they get the 284 over 3? What they did was they divided the 2 and the 8. Here, 2 goes into itself 1 time, 2 goes into 8 4 times. So 71 times 4 will be 284, divided by 1 times 3, which is 3. So now you have 284 over 3. Divide 3 into 284, you're going to get 94, with 2 left over, so it'll be 94 and 2/3. But we drop off the 2/3 because we want the integer part of the answer, the whole number part. So 94 towels can be made. And part B, how much material will be left over? Okay, the division was by 3/8. So the amount of that material left over will be 2/3 of the 3/8. So 2/3 times 3 over 8. Again, 3 goes into itself 1 time, 2 goes into 2 1 time, 2 goes into 8 4 times, which will give you 1/4, because the numerator will be 1 times 1, the denominator will be 1 times 4. So 1/4 of the material will be left over. Here's another example. A bookstore has a shelf that is 37.5 inches long. Each book that is to be placed on that shelf is 1.25 inches thick. How many books can be placed on that shelf? Now here we need to find how many 1 1/4 there are in 37.5. So this is a division problem here. And this is another way of writing a division problem. 37.5 over 1 1/4. And here's how that problem is worked out. They converted 37.5 to 75 halves. And 1 1/4 was converted to 5/4. And then the next step is to invert 5 over 4 to 4/5 and multiply it by 75 over 2. Now here they just did numerator times numerator. That's 75 times 4, which is 300, over 2 times 5, which is 10. So you have 300 over 10, which is 30. So to answer this question, 30 books can be placed on that shelf. Okay, now let's look at estimation and mental math with rational numbers. Estimation and mental math strategies that were developed with whole numbers can also be used with rational numbers as well. Let's say we want to estimate 3 1/4 times 7 8/9. Okay, now they used range estimation. In other words, 3 1/4, two whole numbers that 3 1/4 is in between are the number 3 and 4. So now 3 and 4 are the two whole numbers that 3 1/4 is in between. For 7 8/9, there are two whole numbers that 7 8/9 are in between, 7 and 8. Now multiply 7 times 3, you can get to 21. 4 times 8, that's 32. So the product of these two mixed numbers will be between 21 and 32. Okay, now for 24 5/7 divided by 4 1/8. That's going to be a little bit tricky because the 24 and 5/7, the two whole numbers that number is in between, is 24 and 25. 4 and 1/8, the two whole numbers that 4 and 1/8 is in between will be the 4 and 5. Now we're doing division, so 24 divided by 4, that's the 6. 25 divided by 5, that will be the 5. So that quotient is going to be a number or mixed number between 5 and 6. Okay, next we'll extend the notion of exponents. Okay, a to the power of m is going to be where m is your exponent that tells you how many times a is used as a factor, and it's written like this. And a is going to be any rational number. M is any natural number. And then this one is the power rule, where you multiply powers of the same base, you add the exponent. So a to the m times a to the n will be a to the m plus n. A is not equal to 0, m and n are integers. So here, if you multiply powers of the same base, you just simply add the exponents. And then a to any non-zero a to the 0 power is always 1. Like a to the 0 power is going to be 1. 1/3 to the 0 power, again, will be 1. And then the next one, a to the negative n, that's going to be 1 over a to the positive n power. Okay, so think of 3 to the negative 2. We write that as 1 over 3 to the second. And then a to the m divided by a to the n. This is the quotient rule, where if you divide powers to the same base, you bring over the base, but you're going to subtract your exponents. M minus n. a to the m minus n is what that will end up being. So 4 to the 5th divided by 4 to the 2nd, that's 4 to the 5 minus 2, or 4 to the 3rd. And then finally, number 6 is raising a power to a power. In this case here, a to the m raised to the n, you just multiply your exponents. You're raising a power to a power, so you're going to multiply your exponents. So if we have 6 to the 3rd raised to the 5th, that's just 6 to the 3 times 5, or 6 to the 15th. Okay. That's basically what that rule is saying. Excuse me. Now we have a quotient raised to a power in number 7. When you have a quotient raised to a power, that means the numerator is going to be raised to that power. The denominator will be raised to that power. So a over b, that quotient raised to the m, will be a to the m divided by b to the m. So in other words, 3/4 raised to the 4th. The numerator, which is your 3, that's going to be to the 4th. The denominator, which is 4, it will also be raised to the 4th power. And then number 8, a, b, the product of a and b raised to the power. That means you take each term and raise it to that particular power. So the a will be raised to the m and b will be to the m. So in this case here, let's say 2x, and then that's to the 4th power. That means the 2 has to be raised to the 4th power. Also, the x must be raised to the 4th power. Each number and each variable inside the parentheses is going to be raised to the 4th power. Number 9, this one has a negative exponent. You have the quotient raised to the negative exponent. This we can write as the reciprocal of a over b, which would be b over a, raised to the positive exponent. Okay? So if I have 4 over x, and that's raised to the negative 3, I can rewrite that as just simply taking the reciprocal of 4 over x, which is x over 4. And then that negative 3 will change to a positive 3. Okay, look at this example here. Here we want to use the properties of exponents to justify the equality or inequality. Here I want to show that negative x raised to the negative 2nd power is not the same as negative and then x to the negative 2nd power. Okay? We're going to work both sides of this particular situation here. Let's look at the negative x in parentheses, and it's to the negative 2 power. Another way I can write that as 1 over negative x to the positive 2. I'm using one of the properties of exponents. We have a to the negative n, that's 1 over a to the n. So negative x in parentheses to the negative 2 will be 1 over negative x in the parentheses, and that's going to be squared. Now, negative x and u squared is negative x times negative x, which is going to be a positive x squared. That's the left side of this equation. The right side, bring down the negative, x to the negative 2, that's 1 over x squared. And I'm done with that problem. Now, does this equal to this? No, it doesn't. It's almost the same, but it's got the negative sign here. Here, if you leave off the parentheses here, what you're saying is that you're going to do this first and then you take the opposite. In this case, you're going to write it like this and then you square it. So that's why the left side is not the same as the right side. Okay. Now let's look at this one. You got negative x in the parentheses to the negative 3. And I want to show that it's equal to the opposite of x to the negative third power. So this is part B right here. Now what I'm going to do here is, on the left side, I'm going to write this as 1 over negative x, and that's going to be raised to the positive third power. Now, a negative raised to an odd power is going to be negative. So I can go ahead and put the negative there, then put 1 over x will be to the third power. So I get negative 1 over x to the third power. Now on the right side, bring down the negative, but that x to the negative third will be written as negative 1 over x cubed. And I'm done with that side of the equation. This does equal to this. Okay, so negative x in the parentheses raised to the negative third is the same as the opposite of x to the negative third. Okay. And I also want to show that AB to the negative 1 is not the same as AB in the parentheses raised to the negative 1. Okay, now take a look at this. Now, only the b is raised to the negative 1, so the a will be on top. The denominator, the b will be in your denominator. So this will end up being a over b. Now on the right side, the a and the b are raised to the negative 1. The whole expression inside the parentheses is to the power of negative 1. So I write that as 1 over ab. Clearly you can see that these two expressions are not the same. So ab to the negative 1 is not the same as the product of a and b raised to the negative 1. Okay, this one, part D, a to the negative 2 times b to the negative 2, and that's raised to the negative 1, and you want that equal to a squared b squared. Okay, think of this. We're raising a power to a power. We're raising a product of powers to a power, so if we rewrite this, this will be a to the negative 2 raised to the negative 1, and then b to the negative 2 raised to the negative 1. So for each one of those, we're raising a power to a power, so we can multiply the exponents. Here, for the a, negative 2 times negative 1 would give me a squared. For the b, negative 2 times negative 1 would give me b squared. So here, this will end up being a squared b squared. Now for this one, a to the negative 2 plus b to the negative 2, that quantity is raised to the negative 1. And it does not equal to a squared plus b squared. Okay, now I'll do this one. Okay, let's complete the left-hand side of this particular statement. All of this is to the negative 1, so what I'm going to do here is rewrite this as 1 over, or better yet, I can just do all of this inside the parentheses. Rewrite that a to the negative 2 is 1 over a squared, plus b to the negative 2 will be 1 over b squared. Then that's raised to the negative 1. Now here, I'm going to add these two by finding a common denominator, which will be a squared b squared. All this to the negative 1. Now, I'm missing a b squared, so I need to multiply the numerator and the denominator by b squared. So this will be b squared here, plus, in this 1 over b squared, to make this a squared b squared, I need to multiply the numerator and the denominator by a squared. So this is what I'm going to have, b squared plus a squared over a squared b squared. Now, I can change this to a positive 1 power by taking the reciprocal. So this will be a squared b squared over Let's say this. B squared plus A squared, that's the same as saying A squared plus B squared. I'll write it like that. And as you can clearly see, this is not the same as this. Okay? So you can see A to the negative 2 plus B to the negative 2, that quantity to the negative 1 does not equal A squared plus B squared. Okay, here we're going to write each of the following in simplest form using positive exponents in the final answer. Here we got 16 squared times 8 to the negative 3. Okay. Okay. Okay, the common base that I can use for 16 and 8 will be 2. Because 16 can be written as 2 to the 4th, and then that's going to be squared. That 8 can be written as 2 to the 3rd, and that's going to be raised to the negative 3. Now we're raising a power to a power, so we're going to multiply the exponent. So here, 2 to the 4 times 2 will be 2 to the 8. And this one will be 2 to the 3 times negative 3, which will be negative 9. Okay. Now we're multiplying powers of the same base, so we can add the exponent. So here, 8 plus negative 9 will be negative 1, so we're going to end up with 2 to the negative 1. Now we can write 2 to the negative 1 using positive exponents. That's 1 over 2 to the 1, or just 1 over 2. So this will end up being 1 over 2 as the final answer. Okay, this next one, 20 squared divided by 2 to the 4th. Okay, now for the 20, let's see, if I write this using prime factors, this will be 2 times 2 times 5, and all of that squared, divided by 2 to the 4th, or 2 squared times 5, and all that's still going to be squared, and that's divided by 2 to the 4th. All right, in this case here, that 2 to the 2nd is going to be squared, raising a power to a power, you multiply your exponents, that'll be 2 to the 4th, times the 5 is also going to be squared, so it'll be 5 to the 2nd divided by 2 to the 4th. Now, if I write it like this, 2 to the 4th times 5 to the 2nd, and all that's divided by 2 to the 4th, you can see 2 to the 4th, that's going to be gone. You'll just simply be left with 5 to the 2nd. Or you can write 5 to the 2nd as 25 if you like. In this case, they left it as an exponent. In exponential form, 5 squared. Okay. Let's look at this one. Part C. We got 10 to the negative 1 plus 5 times 10 to the negative 2 plus 3 times 10 to the negative 3, and that's multiplied by 10 to the 3rd. All right, in this case here, we're going to use the distributive property. 10 to the 3rd will be multiplied by each and every term inside the parentheses. There should be a plus sign there. Okay. So, here's what we're going to have. This 10 to the 3rd will be multiplied by 10 to the 1, so it'll be 10 to the negative 1, so it'll be 10 to the negative 1 times 10 to the 3rd, plus this will be multiplied by 10 to the 3rd, so it'll be 5 times 10 to the negative 2 times 10 to the 3rd, plus, and then this last term will be multiplied by 10 to the 3rd, so you got 3 times 10 to the negative 3 times 10 to the 3rd. Okay, now we're multiplying powers of the same base, so we know we're going to have to add the exponents. Like 10 to the negative 1 times 10 cubed. Add the negative 1 plus 3, that will give you 2, so it'll be 10 to the 2nd plus 5 times 10 to the negative second plus 3 will be 10 to the 1, or just 10. Now if I add negative 3 and 3 here for the tens, that'll be 0. So I have 10 to the 0, which is 1, times that 3, which is 3. Now let's simplify this. 10 to the second is 10 times 10, that's 100. Plus 5 times 10, that's 50. Plus the 3, which will end up 153 as your final answer. Okay. And this one is kind of like a algebra type problem. X cubed, y to the negative 2, raised to the negative 4. Okay. We raise each term that has a power to a power, so we're going to be multiplying those exponents. So here for the x, we're going to multiply 3 times negative 4, which is negative 12. And then for the y, negative 2 times negative 4 will be positive 8. So you have x to the negative 12 times y to the 8. But I'm sure we want this as a positive exponent, so here the y to the 8 will be on top. The x to the negative 12, you're going to put that in the denominator with the positive exponent. So it'll be y to the 8th divided by x to the 12th power. Okay, and that will be that final answer right there. Okay, so that would conclude this particular section on the multiplication and division of rational numbers.